Okay, thank you very much. Thank you so much. So my name is Alejandro Cuenca. I'm a research engineer here in Gradiant, which is the technology center coordinating this project named Trusted. The full name of the project is Enabling Trustworthy European Data Spaces through Self-Sovereign Identity and Privacy Preserving Technologies. These three concepts are the main ones, not the only ones, but we should have them very present here. This project is aligned with the European strategy for data. Here you can see the consortium participants. And the reason why we need a project like this is because of the value we see on sharing data. As Francisca was explaining just before, not only Europeans see value on sharing data, but in Europe we need to tackle some principles or regulations that protect people. So as Jaime and Francisca have gone through some of the issues, we can briefly talk about them. Before self-sovereign identity, there were some issues on identity because of how centralized or federated identity management approaches work. Before data spaces, there was some issues, or there was a lack of a trust framework for sharing that data in a standard and compliant way. Also, before federated learning, there was some data that could not easily be that it shouldn't be shared. For instance, health data is so sensitive that it should not be moved from one actor to another. Federated learning possibilitates some options on that. And it can be, all these slides can be summarized as one big issue that would be the lack of trust. So in Trusted Project, we have a goal that we can see split it here in two parts, even if they are interconnected. On the one side, we have a federated learning service that makes use of several PETs or privacy-enhancing technologies. This service will also make use of data spaces for sharing the information, also for the contract negotiation, and having some policies. It will possibilitate the AI study of siloed datasets, meaning that the data will remain in control of the data owner, and only the model will be shared when training it. Also, it will provide some privacy guarantees. And on the other side, we can think of, we can provide a self-sovereign identity management service that will be aligned with the UDI wallet in order to possibilitate exchanges within the European identity framework in a eIDAS version 2 compliant way. For the onboarding of natural people, there would be the use of AI-based document validation and also multimodal biometrics, voice and facial recognition. There would be a specific way to treat consent. And some other privacy-enhancing technologies will be applied. In this case, it would be selective disclosure and zero-knowledge proof. So these are the main concepts that we can see in Trusted. Self-sovereign identity, privacy-enhancing technologies, federated learning, and data spaces, they are all interconnected. For instance, self-sovereign identity and federated learning apply their own PETs for privacy enhancing. And then data spaces or federated learning make use of data spaces for sharing the data, and data spaces make use of self-sovereign identity to mutually authenticate participants of the data space, also outside of the data space in case it's needed. So if we dive into the SSI-related privacy-enhancing technologies, for both digital wallets for natural people and legal entities or relying parties. We should be providing, for instance, selective disclosure using MDocs or the MDL, the mobile driving license format for identity exchanges when providing a PID or a legal PID for legal entities. For other type of qualified electronic attestation of attributes, the selective disclosure could either use MDocs or SDJOTs. And then for electronic attestation of attributes, unlinkable selective disclosure could be used with linked data proofs and BBS. And that's, let's say, the basics. We also want to explore advanced selective disclosure mechanisms, for instance, with the combination of BBS with MDocs or W3C JOTs for identity credential exchanges. Here we're always referring to OpenID for verifiable presentations, but it could actually happen that we are also using the centralized claims protocol, as it looks like the main option for data spaces right now. There's an open discussion in May, June 2025. So we'll see how it evolves, but it could also happen. And last but not least, we are thinking of supporting serialized proof predicates of attributes. This doesn't close the door for other options. We could also explore other type of privacy enhancing technologies. For instance, we can talk about post-quantum safe options, but I didn't include them here in this slide. And then for the federated learning related privacy enhancing technologies, my colleague Georg will go through them in a more detailed way later on. But for now, we can just say that they will be integrated in a federated learning core, and that there are 3 different organizations preparing bets for this project. Fraunhofer AISEC, the AISEC department, would be in charge of functional encryption and multi-key homomorphic encryption. Gradiant will have their own schema for secure multi-party computation, and a different one, multi-key homomorphic encryption, and Trialog will apply differential privacy and secure aggregation. This is just a brief overview on how the federated learning would work. Of course, the data owners will preserve the private data. It will not be shared. Only the model updates and the aggregated models will be shared during the different iterations of the training of the model. And different bets will be applied here. You can also understand that all this is happening through the data space that would be created specifically for this, and should be aligned with the European data space for health, the health data space. And this is an old image from the proposal of how the solution could be. Here you can see the minimum viable data space, not the official component called minimum viable data space, but an ad hoc one that we will prepare using the self-sovereign identity that we're proposing, using wallets, instead of having a centralized identity provider as most in production data spaces used right now. Of course, not only Gaia-X, but also important actors in the data space communities are creating these new options for self-sovereign identity. And we can see the trust chain through different trusted issuers. For instance, there would be PID providers, also legal person ID providers. There would be a data space governance authority that would be the one that decides which legal entity can be part of a data space. And for that, there would be another issuance process for a membership credential. And then once the participants are able to authenticate to each other, they would be using different components related to data spaces to share any type of data set or service offering, and they would be able to negotiate the contract after they have found it in the federated catalog, as we can see here. So the two main use cases that we work with are one related with medical data or health data for that federated learning training. And then another use case would be for the volunteer services that could also be using in the case of the volunteers, they would be focusing more on the specifics of the identity data. For instance, they will have a volunteer credential or a volunteer card that would allow them to access different services for volunteers. So this is, well, of course, for the discoverability, the participants can make use of a self-description tool to publish their data sets or service offerings in the federated catalog. Here we are using OCM and PCM as, you know, in Gaia-X, this is what they're called, the organization credential manager or the personal one. But the point is that we are planning to use the European Digital Identity Wallet because it provides with the same functionality as some of the components here. So for those components that can be, that the UDI wallet can be used, we will be using them. So this is a very brief explanation or overview of the Trusted project. Of course, there will be many more things to talk about, but we lack the time. So I hope you can reach us. There are some sister projects in this webinar that come from the same call as we do, and we are totally open to collaborate with them. And yeah, please feel free to reach out, and thank you for your attendance.
I suppose I'm the next, correct?
Yes, Luca, it's your turn now. We give you the remote control.
Thank you. So good morning, everyone. I work as an innovation manager at InfoCert and also teacher of distributed systems at the University of Padua. My task here is, with respect to what has already been presented by Jaime and Alessandro, to give a more precise place of where Trusted initiative stands with respect to the EU identity wallet. So it is a limited task and kind of bridge between what is done within the project and what's currently ongoing in the European scenario with respect to the deployment of the European wallet. So I think I can move slides myself. Can I?
Yeah, Luca, you should pass the presentation yourself.
Okay, now I see. Thanks a lot. So this is the brief agenda I'm going to present now. First part will be on EIDAS 2 identity wallet. Several things have already been mentioned, so I'm just summing up in order to bridge within the second part, which is Trusted. And as for the overview, you probably know already what is necessary. I would like to focus a little bit on how trusted might contribute to the European initiative toward an EU digital identity wallet ecosystem, especially with respect to the specifics of trusted project, which is using the wallet for data sharing. So let us start from the first part. And here you see, and now I will briefly recall to everyone, for those who are not already into that, what are the requirements of the European Identity Wallet, what are the main milestones, how it intends to address a few use cases, and who are the stakeholders in this, which is intended to be a EU-wide ecosystem. Okay. As for the requirement, this is something which comes directly from the specification of the regulation, EIDAS 2.0, and which is now being, specified by means of implementing acts. First round of implementing acts has been issued on November 24, second round, May 25, so just 1 month ago. These implementing acts are, in fact, kind of paving the way, defining which specific standard should be applied in specific cases. As for the requirement, it's clear that one of the most important requirements of the wallet is security and trust. So there's a requirement for the wallet to support high assurance level. In some cases, it will leverage on a substantial level. You know that this level of assurance have been defined already in EIDAS 1.0 with implementing that's 1.502. But here we are kind of applying it to the specifics of the wallet, and the architecture already mentions how a wallet secure creation device and secure creation application should be used in order to grant the high level. Now, wallet should be also be assessed. So there will be a formal process of assessment of the wallets by conformity assessment bodies in such a way that they fall under, say, a complete trust framework as currently other trust services. Then, as for the functional content, this you already know, and as already mentioned, it should support PID for natural person, but also legal PID for legal persons. It should support both the collection and the spending of qualified electronic attestation of attributes. Alejandro already mentioned several technicalities for that. It should support interoperability through the protocols which have been mentioned, especially the references directed to ISO 18013-5, which is the standards for machine driving license, which is also being extended to other type of credentials. And the protocols to be used are the OpenID for VCI and not OpenID for VP. The point is that the credential format should be, of course, common to everyone. So either doc or what's mentioned in the implementing acts now is W3C credentials, which we think we can implement physically as SD-JOT credentials. Back to the part of user control. Of course, there will be need of the user to be in control of its own privacy and its own data, and it's very much related to what trust is going to do. And it should respect, of course, the GDPR as for compliance. Selective disclosure and zero knowledge proofs has already been mentioned, so I'll skip over. Now, the point is that it should allow authentication to both public and private services. As you know, there's a strong requirement for, say, big players as well to need to support the wallet as one of the ways for authenticating, including financial services, which is a very strong point. It should also support both remote and proximity scenarios, and in some cases, even offline capabilities. Additionally, it should support signing the document via qualified electronic signature, which is the strongest form of digital signature, which is completely equivalent, if not above the handwritten signature, which is was used in the past. Now there will be a national authority supervising the wallet, and there will be a complete, say, schema for accreditation. Okay, that for the requirements. So you know what the European wallet will be once it will be deployed. As for the, let me move forward. No, can't move forward. Yes. Back to a few slides. No, it was me pressing too many times, perhaps. I can't move back.
About Luca, because there's some tech problem right now. It went very fast.
I understand. Apologize. I'm trying to go back to my now perhaps I should have got control. Yes. Okay. This is about the milestones. So, sorry. Trying to move my slides. Okay. Too many times again. The next point I would like to make is how this process is going to be performed by the Commission. Oh, it takes definitely long to align to my needs. And as in fact, that this, you know, that there has been formal adoption, implementing acts. Now, member state wallets are now going to be implemented, and we expect wide acceptance by the end of 2027. That's what has been foreseen. There are 4 different, say, steps that the Commission is now pursuing in order to achieve, implement this environment for wallet. First is, of course, the legislative project, which you already mentioned. We started with the IDES 2.0 and with the following implementing acts. Then there's a technical specification, which is performed by a group of an expert group, which is going to produce an architecture and reference framework, which is publicly available, and you can comment, and there are a lot of work on that. Additionally, there's a wallet reference implementation, which has been commissioned by new Commission, and which already released a very large set of libraries, software components, which can be reused by member states. There's no obligation to use them, but they form a very significant base for prototyping, testing, and full functionalities. Many countries are basing their own development on these reference implementations. Others don't. They are implementing their own stack from zero. But this reference implementation fully satisfies the standardizations which are being defined in the normative process. Fourth step is the one of large-scale pilots. There has been already 4 large-scale pilots which has been launched in 2023 and are completing this year, mid this year, which are NOBID, Potential, DC4EU, and EWC. They delivered a set of experimentation in several use cases. They are now closing, but there are an additional 2 large-scale pilots, which will start September, October this year. My company is involved in both of them. One is Aptitude, the other is WeBuild. And one of them is more focused. WeBuild is more focused on organizational wallet and onboarding of legal entities and payments for legal entities, etc. Aptitude is more focused on natural persons for several use cases, including travel, payments, and a few other minor use cases. This is the set of use case which has been mentioned, but I will just refer you to this link that you see here. It's about the many different use cases which have been promoted, but I will skip over this for the sake of speed. Now, who are the stakeholders? Who's going to play a role? This is the important point. Is this just a public initiative, or there are private actors involved? And in fact, the ARF, Architecture and Reference Framework, defines a complete, say, scenario ecosystem where there are both public entities which are in charge and must, by law, provide citizens with a wallet, but there are also a set of private operators which may play a role, especially in some fields as provisioning of additional attributes. The PID, which is the most important and core attribute, would be provided by the member states, or at least under strict control of the member states. Other certificates, which might be, say, driving license, well, yeah, driving license is normally under the state control, but say educational certificates or health certificate or banking financial certificates or whatever you want, professional course certificates, they would be provided even by private entities, which might both produce attestations and consume attestations. So this would define a complete area. The point is now, who's private entities which are willing to play this role? Which kind of business would they find? And this is what's going to be defined even from the marketing studies. Okay, then this said, the second step would be, if I'm allowed, moving toward trusted, and especially, no, I can't skip to the next slide. It's a bit unfortunate. Okay, now I can, yes. So a trusted overview will be very short, since you know already from previous presentations. What I would like to focus about is trusted contributions to the wallet ecosystem. So the wallet ecosystem is already being shaped. How can trusted contribute to that? What is its role? And specifically, what is the role of the partners which are now running the trusted project? How can they leverage on this project in order to find a more precise role into the wider ecosystem? And then last, on data sharing, which has been already mentioned by the colleagues who spoke about Gaia, etc. So as for the overview, this I will skip, since you know, and I would just like to use this as a reference point to what I believe are the main contributions. And I would use this diagram in order just to place them in some specific areas. The first one that I see is enhanced identity proofing for natural persons. Trusted has a strong competence on biometric identification and the identity proofing process, which is the process by which a user will gain his initial PID data, but may also be used for later authentication. This is one of the areas which is more open to, say, public or private initiatives. So I think we may find developing appropriate technologies here might allow for, say, filling this role. There's a standard which has provided by ETSIDS 309461, which specifically defines what are functional requirements for identity proofing, and trusted would abide by that standard in order to be compliant to the requirement, to the strong compliant requirement of UD wallet. Second point that I believe is crucial contribution of trusted is for legal persons. So we also deal with legal persons, since who's going to play a role into the sharing of data would be largely private companies, not persons. So it will be hospitals, it will be pharmaceutical institutions needing more data, it will be organizations of volunteers, of organizations using volunteers, which are the use cases of trusted. And for this, we will need to have a wallet which is not just for natural persons, but a wallet for legal persons. Of course, a wallet for legal persons is a completely different story. It's normally a hosted wallet, so a cloud wallet. And this would be probably one of the largest contributions that trusted would give, since the hosted component of the wallet is not well developed yet, neither in the reference implementation nor in the architectural framework. So I think we might even promote our implementation as a possible base for the future standard, which is what we call the business wallet, which is now in process of being fully defined. There's a first step, which is connected to the first, which is the cloud wallet. So first was about the registration of a service provider. So there's an identity proofing, say, stage, even for legal persons. Then there's a wallet for legal persons, which is one of the core part of trusted. Now there's an additional point is about the use of what we call self-signed credentials, since Trusted designs a model for people to say describe what they are going to produce to the data ecosystem. And this would be something which is not credential issued by some third party. It would be something which the owner of the data himself will be able to sign. This model, which is broadly termed self-signed credential, so it's a credential that I myself declare, will be used for, say, describing my own data asset, but it will also be used in a variety of other different scenarios, which are not directly addressed by Trusted, but for which Trusted would provide a basis, a technological implementation base. Well, last note I would like to make is about data sharing, but this is already been dealt with. So what I would only like to remark that there are many different ways in which a wallet can be used for a data space. It has already been mentioned by Jaime and colleagues that there will be need for strong authentication of stakeholders. If I'm going to put my data into place, I'm a company, I'm putting some data into the market, or if I'm some company consuming data, or if I'm a user willing to access the system, I need to be strongly identified because of the strong need of privacy and protection of data. And this is one of the places. There might be, and Trusted is going to explore other ways of using the wallet. For instance, the wallet as a way to control my personal data, which is located somewhere else. Think of my data which stays, let's say, of Google, or stays on some provider, Amazon, or whatever. It might be possible, and we would like to investigate on this option, to use the wallet as a way, and not just to access services, but as a way to convey the right to access my data, which is hosted to some other places. And this is probably one important place that we might investigate further. That's more or less what I wanted to add to this discussion. Let me see.
Thank you so much, Luca. Thank you for your time, for sharing this presentation with us. Now, time for our colleague, Georg Brown.
So hello, everyone. I have the honor to present to you the topic Federated Learning in Pets and Trusted, a framework for secure and centralized data sharing. And how do I get to the next slide? Okay. A little bit about myself. My name is Georg Bram. I received my Master of Science in Informatics at the LMU Ludwig-Maximilians-Universität in Munich. And since 2016, I'm a research associate at the Fraunhofer Institute of Applied and Integrated Security. And since 2020, I'm also doing my PhD there, which is about computation on encrypted and unstructured data. And the Fraunhofer AISEC is a research institute. We have a lot of research departments, and even I myself, I'm part of the APT, that's Applied Privacy Technologies department. So we are researching as the title suggests, applied privacy technologies. And so I was a little too fast, and this was about me. So what are we going to talk about? As you just heard, I'm specialized in privacy technologies. So we are talking about why do we apply privacy technologies in Trusted. And then we are going to have a look at these privacy technologies in detail. This is an abbreviation for it. PETS means privacy enhancing technologies. And finally, we're going to have a short look how do we embody it in the data space. So we begin, why do we do that at all? So currently we have the data siloed in, for example, multiple hospitals all over Europe. And if we want to do machine learning, it's a very, very complicated process because we have privacy regulations, sometimes even privacy regulations specific to a specific country. And it would be very fine if we digitalize the system that we also can do federated machine learning on these siloed data, but possibly or optimally without centralizing the data. So of course, we can apply federated machine learning here. That's a technique where machine learning is split into multiple machine learning clients which collaborate and then provide the data for a global machine learning model, which is then updated, and the updates are then sent back to the clients, and so on and so forth. And so the model grows. But this alone is not privacy protecting, sorry, at all, because these updates, these gradients, or there are also other possible updates, they of course can leak data. And we want to ensure in Trusted that these data leakages are minimized. So then we can have strong privacy guarantees. How we do that? We introduce so-called privacy enhancing technologies. And these privacy enhancing technologies are there to protect several stages of this process. Some are there to protect the training, some are there to protect the aggregation or the inference. And they first and foremost enable they enhance foremost the data privacy level in the machine learning process. Now, in the current research, there are multiple different prototypes that are able to do this. And we, in this project, concentrated on a few examples, which we're gonna have a look in detail. Namely, we are currently developing two multi-key homomorphic encryption systems. We at Fraunhofer are working on a functional encryption-based system. And there are also three other candidates developed by partners in this project, namely a differential privacy-based one, secret sharing-based one, and a secure multi-party computation-based one. And to give you a little bit of an insight and a little bit more details, we're going to talk about these 5 different categories, whereby the first category, as I said, is implemented by 2 partners, one prototype by us and one prototype by Gradiant. So what is this multi-key homomorphic encryption? As the title suggests, it uses a technology called homomorphic encryption, which allows the computation on encrypted data. So, for example, we have down there multiple hospitals that share their data and compute a local machine learning model. Then they encrypt their update. Then this is what here is titled shared data. Then they send their encrypted update to a central model aggregator, which receives the ciphertext and does not have to decrypt it to read it or compute on it. But thanks to this homomorphic encryption technique, you can compute on those ciphertexts and enhance the model without decrypting the ciphertexts. And then the result of this model update in encrypted form again gets sent to the hospitals, which update their local model. And so again, we have a circle of machine learning. The problem is here, this might arise when using this technique, is that this homomorphic encryption, of course, introduces a huge overhead. On the computation platform at the aggregator, it uses a computational overhead, and on the transfers, it uses a communication overhead. So maybe for some machine learning problems, it might not be fast enough. That we will see. It's a matter of research currently. And furthermore, some of these homomorphic encryption schemes are restricted to a specific range of precisement. So maybe in some machine learning problems, we lose some precision. So this is also a matter of debate and research. So this was the homomorphic key encryption-based PET. Then we at Fraunhofer are developing a functional encryption-based. This is, the technique itself is aligned to homomorphic encryption, but it's not exactly the same because again, we have this circle of global aggregator here in this cloud, and we have machine learning clients. The clients, again, encrypt their data using this functional encryption scheme, and then they send the ciphertext to the aggregator. And in this case, the aggregator has to decrypt this stuff to read it and update its global model. But he does not learn anything else but the outcome of the machine learning update. So he does not learn anything about the local model or the local data at the machine learning clients or the hospitals, but he only learns the updates. So this protects the local models, but it does not protect the global model from the aggregator knowing the global model. But of course, as we do not have the computation overhead here, it's much faster and we do not lose precision. So it has, of course, some advantages. And as you see in these talks, some of the schemes have introduced advantages, like they raise the privacy level, but they also sometimes introduce disadvantages, for example, lowering the precision. As I said, we do also have other privacy-enhancing technology candidates, like this differential privacy candidate, which not tries to protect the privacy by doing encryption and the transfer and at rest, but this is a little bit different here. When training the model, there is a little bit of noise injected into the original data, so that during the aggregation, the privacy is enhanced by adding the noise, but of course the precision is also lowered by introducing the noise level. But if you want to know a bit more about the differential privacy PET, then maybe you can contact the three who are developing this, and who are also developing, oops, this was too fast, the symmetric sharing privacy enhancing technology part. Here, the updates which are generated by the machine learning clients are split into so-called shares. So they do not transfer one complete update, but they split their update into shares, and each machine learning client does that, and then the shares are mixed together and combined again, so that the aggregator can combine the shares, but without knowing which share which data source is behind the share which is coming in. So it's also a very fine and very nice idea, in my opinion, because we do not have a huge overhead, and it does introduce a high level of protection. And then finally, we have the secure multi-party computation privacy enhancing technology by Gradiant, where in this graphic there, the machine learning clients are depicted as nodes, and they compute their outcome of their local machine learning model, and then it's a little bit more complicated because we begin at 1, and 1 is the encoding up here, and after the encoding, shares are given to the machine learning clients, and then the machine learning clients use those shares and compute updates and communicate this again to the master, and the master, it's decoded, and this enables secure aggregation of the updates at the master without knowing exactly the specific source node. But again, if you want to have more detailed insight into this privacy enhancing technologies, you can of course contact Gradiant, who's behind it. So, in conclusion, we do have currently in the development 5 different technologies for privacy-enhancing technologies to be used in the federated machine learning process in a service in the trusted environment. And each of these techniques introduces a specific raising of the privacy level. So we have some who do a strong guarantee because nearly everything is encrypted, and some do a more moderate or more formal privacy level raising. But of course, they again do not introduce such a high overhead as the cryptographic computation ones. And of course, they are suited for different machine learning stages because for example, MKHA one is optimally suited for the training inference. The functional encryption is optimally suited for inference, and the SEC secret sharing is optimally suited for aggregation, and the last one's for the training. So in conclusion, how do we embed these technologies into the data space? That's my last slide. As you see, some of these technologies map to different federated learning stage pipelines. And what we are currently researching here at Fraunhofer AISEC is, of course, how can we possibly combine those paths? So, for example, if we use 2 or 3 paths in composition, which influence does this have? How do we combine them? Do we even can combine all of them, or are there problems when combining specific ones? Which influence has this on the speed and on the accuracy? And of course, we are currently working on the integration of these technologies into the trusted framework, which is, of course, the data space. There are some legal constraints, technical constraints, but also social constraints we have to talk about. So, in conclusion, these paths are really cool and essential enablers for a high privacy level in trusted federated machine learning process. We don't have one-fits-all solution in paths because some are suited for specific problems, some introduce problems, and in my opinion, composability of those different paths in usage is the key. And of course, the trusted principles help to assess this path alignments in the federated machine learning. And in the future, maybe we have some automated path orchestration using a new federated machine learning framework by Gradiant. And of course, a question that's always behind in our head is the post-quantum readiness of these problems. Some of the schemes are already post-quantum ready because they're using techniques like lattice-based encryption. Some of them are not, but currently we do not have this problem, but of course we do have it in our head. So I gained a little bit of time. I hope this is okay. Thank you for listening, and that's all from my side.
Thank you so much, Georg, for sharing all the information and your knowledge with us today. And we went to the final part of our webinar, our online webinar. How is the European Union advancing in digital identity and data privacy initiatives? For this part, we have some important guests for us. Thank you so much for sharing your time with us today. I'm going to introduce you Diana Jimenez. She's an electronics engineer with global experience across different countries all over the world, and she leads new innovation projects at Trialog in Paris. Now she's the coordinator for LICORICE project. After her, we will have Nikolaos Kuriakolis. He's a research assistant and software engineer at the University of Patras in Greece. And he works in the EU project like CONSENTIS and in other initiatives as Escape and the Etsy Open Slice platform. After him, we have 2 additional guests today. Ignacio Ladillo, who is the legal expert in digital identity and trust services and cybersecurity. He's managing partner at Astria, And actually, he is a key legal advisor for the project DC for Europe. It's a large-scale project in Europe. And after him, Laia Botas is a great information science from the University of Barcelona, and she will represent the Spanish General Medical Council, where she works as an advisor. So thank you, all of you, for sharing this morning with us. And we'll share with you, Diana. Diana, it's your time.
Thank you very much. Thank you for the introduction. As I was mentioned, along with Trialog, I represent Trialog in the coordination of the LICORICE project. So first, I would like to present the LICORICE project. Okay. So the LICORICE project is a reliable and scalable tools for self-sovereign identity and data protection framework. So if we play a little bit with the words, we get LICORICE there. And sorry. Okay, maybe ahead. Whoa, that was a lot. Sorry, I'm trying to go back to the slide I wanted to present. Okay, so first I want to present you the LICORICE project, which is an innovation action as a trust set. We're under the same call, and we are reinforcing digital trust, data sovereignty, and secure identity management. We want to deliver advanced self-sovereign identity and privacy-preserving tools. We have around 10 cryptography secure components. For most of them for user-centric identity management, verifiable federated data sharing and computing. We want to contribute and align with the EU digital identity and data strategy. So we contribute to digital decade goals, supporting the ID wallet, the secure EU data spaces, and we fight against cyber threats and identity-related crimes. We have two operational pilots. LICORICE is, let's say, a pilot-centric project. One is the cyber threat intelligence, which is AI-based assistance and sharing, and the second one is e-health and biomedical research activities. We have 12 partners from 8 different countries. For instance, here we have the map. We have us at Trialog, Evident, Atos. We have some partners which actually they are the technical coordinators of the project. Some of them are joining this call as attendants. We have AIT, TUGRAS, Universidad de Murcia, IETS, Universidad de Sevilla, Universidad of CERN, FPK, NECLabs, Forth, and UBTech. So we gather different forces together, which is a very nice synergy to create these new tools for identity and data protection. In here, the idea is that we want to bring a set of tools that will support the advanced privacy preserving and security enabled technologies. For instance, we have the self-sovereignty identity and the digital identity. This is managed by some of our partners, which are researching on privacy and preserving identifiers for the EU digital identity wallets, and also developing decentralized identity solutions. We have also other partners that are working on attribute-based credentials and zero knowledge proofs. In this case, is to use selective disclosure and privacy-preserving attribute-based credentials and linkability via zero knowledge proofs. We also have, of course, the privacy preserving for cyber threat intelligence, and that is related to sharing with anonymization and MIMS. For the cryptographic techniques, partners are working on contributions to privacy preserving cryptography. Cryptobiometric authentication, post-quantum cryptography, cryptography primitives using hardware-based trusts. We also have the privacy-preserving AI and machine learning. In this case, the partners are working on secure neural networks interfacing for APC and homomorphic encryption. advising on privacy by design, some privacy-preserving machine learning. So the idea is that we're going to integrate all of these AI solutions with embedded privacy-preserving mechanisms. Then if we go to the ecosystem of the EU and how we ensure that LICORICE is aligned with the European data initiatives, we have key partners that work on this. For instance, IDS is part of our group. We ensure that there's compatibility with the Data Spaces Support Center and the Data Space Business Alliance. We support data governance, interoperability, and ethics by design. All of this is like working around of different standardization bodies and technical expertise, technical experts on with architectural, legal compliance, and privacy regulations. We are very active on the standardization part. We are involved on cybersecurity and privacy, artificial intelligence standards, IoT, and digital twins. And key areas for standardization contribution will be, for instance, when we try to create a use case, so we have to be really aligned to the real world and how it is applied, especially when we manage health, identity, and smart ecosystems. Also, how is it standardization and conceptual models hard. So we work on frameworks around the self-sovereignty identity, privacy ontologies. Of course, once again, we very focus on the privacy by design and security by design. So we really need to be aligned with what is the standard and what is the rule on the game to really be compliant with this and really be do the design from the core. Also, in the development of architectural patterns, which it would be nice that we all contribute to. Then we have the interoperability and assurance. So the strategic contributions, we could say that are the privacy, self-sovereign identity, data space ecosystems. We have these two pilots, as I mentioned. The first one is the cyber threat intelligence. The goal for this pilot is to validate, well, first the LICORICE tool sets, and then strengthen the cybersecurity operations, in this case using AI and while upholding data privacy. This solution has this, let's say, two different components: the AI-driven assistant, where we also take into account that it's compliant with data protection regulations. So it will be an assistant that we can guide developers on different stakeholders in organizations. And then privacy integration, which is the part that utilizes privacy enhancing technologies to anonymize sensitive information. The outcome, we could say, that is that we're going to promote secure collaboration among different stakeholders and between organizations, and that we can propose a streamlined cybersecurity workflow where with privacy respecting and security in a security environment. Of course, there are many challenges. Some of these challenges were already discussed by our colleagues from Trusted. We have challenges such as automated privacy preserving anonymization. We need to be compliant with the data protection regulations. We need to integrate these PETs, these privacy enhancing technologies, but not compromise confidentiality. Also, if we want to work in the real data, in the real time, with real time the data, we need to really enhance these, but with high volumes. So one of the challenges. And then we also have to promote secure information sharing protocols. So even though we want that in hand, we have to be sure that it's something that we take into account as, let's say, it's something that we have identified and we really work. So all of it is passed and doesn't stay as a challenge. Then for the e-health solution, the objectives is that the tool set will be used and tested for user-centered authentication and secure health data control. In here, we have a little bit more of the solutions that we could say we can apply, although all of the LICORICE technologies and the tool sets are applied for these two pilots. So in the e-health case, the solutions could be the privacy preserving AI. This use case is really related to chronic disease management. with AI-based risk predictions. So we can predict, we have an early prediction. Federal learning for model training, self-sovereign identity, so to empower the control of the user over the data, privacy-preserving technologies. So we have multi-party computational ensure confidentiality. And the outcome will be, but of course, that we can promote and support secure data sharing for research and public health. And this, of course, has to be aligned with the European health data space. And then, of course, we want to promote secure medical data exchange, remote monitoring, and privacy-aware telemedicine. The challenge in this case was again data silos. With all of the regulations that are in place that could limit in the data sharing and the AI-driven care, the AI-driven healthcare innovations. We need to be sure that the patient trusts us and they can really, they feel that the data is protected. So for that, we have to mitigate risk and protect really reputation, expand telemedicine opportunities because I mean, nowadays we have started to have, at least here in France, we already have these towns where finding a doctor is quite complicated. So this is really a need at hand. And ensure long-term sustainability so we can safeguard against evolving cyber threats. I mean, hospitals, clinics, and everything health-related is like a target a lot of times. So we need to really safeguard that. And then we have the build the stakeholders' confidence. So here I want to propose to all the different sister projects, the projects under the same call, some contribution, something that we could do together so we can enhance the tools for identity and data protection. So some ideas here. There are some links of the projects. So the idea is that maybe we could collaborate on an analysis document, identifying, for instance, stakeholder needs, the concerns, what could be the security privacy needs, what is the analysis that we have at hand, how we can justify the use of certain controls, all the building blocks, and the common categories, of course, the wallets and the IDAS-based building blocks. Then we can be assured that we are conform with regulation and the standards are harmonized, and that we are together contributing to this standardization. And maybe a milestone could be to have a landscape document together. For instance, we could have like some survey, some concept mapping to link the different concepts on our projects and identify common standards. And then the common standard contribution could be, as we already have discussed, we have kind of the same topics. So contribute to SSI by design, the management systems, the reference architectures and patterns, information models, and interoperability profiles. And why not having a synergy on open source too? Thank you very much. These are our partners in LICORICE. Please follow us on LinkedIn and the webpage. I'm going to share with you the link in a few seconds. Thank you.
Thank you so much, Diana. And now we have Nikolaos Kyriakoulis from CONSENTIS project and the University of Patras in Greece.
Okay, thank you very much for the introductions. My name is Kyriakoulis Nikolaos. I am a research assistant and software engineer at the University of Patras, and today I'm representing the CONSENTIS project. So the full name of the project is Identity and Consent Management for EU Digital and Data Strategies. It's a Horizon funded project. It lasts 36 months and we are currently on month 8. The consortium consists of 12 partners in total across 9 member states. Aegis IT Research is the coordinator of the project. ITML is the technical coordinator. And there are multiple partners which are experts in fields like consent management and identity management, like University of Patras, Maggioli, and Siemens. So to build some motivation about the project, let's take a look at some key challenges in consent and identity management. The first one is the inconsistency between implementation of consent mechanisms developed across member states, which creates problems in the interoperability between them. A second one is that users are often unaware of what they consent to because they have to deal with complex and unreadable consent forms. A third one is a struggle to balance EU regulations like GDPR and EIDAS with the developed solutions. Another challenge is that there are siloed identity systems and centralized solutions that hinder the cross-border data sharing. And finally, there are multiple security and privacy risks, like centralized solutions that increase the risk of data breaches and the insufficient user control over their data. So the vision of the CONSENTIS project is to address all these challenges under the EU regulations, like EIDAS and GDPR, and to introduce a user-centric framework for personal data management. The key features that the project will rely on are self-sovereign identity, innovative consent management solutions, user-friendly interfaces which will support real-time notification. CONSENTIS will be agnostic to existing services and data formats. It will comply with legal standards and regulations. And finally, it will offer continuous evaluation of security risks and regulatory factors. So the mission of the project is to empower individuals through a user-centric framework while guaranteeing control over their personal data and building trust and security in data exchanges and digital interactions. For that, CONSENTIS will utilize innovative and state-of-the-art technologies and solutions such as blockchain, self-sovereign identity, and privacy-enhancing technologies, and it will promote ethical, transparent, and secure data practices. Summarizing, our goal is to offer a complete solution that will address the needs of all stakeholders. It will operate across various domains and contexts, and it will be fully compatible with existing systems, protocols, and formats. The key objectives that the CONSENTIS project will try to achieve are, of course, to address the critical issues of identity management, consent management, and personal data sharing, to deliver a complete framework which will be agnostic to existing services and technologies, to align with EU strategic initiatives, regulations, and legal frameworks. We also want to validate our work in multiple real-life scenarios and business cases. And finally, to connect with external stakeholders in order to promote the project results and receive valuable feedback as we aim for high impact. The concept of the project can be depicted in the following picture. We identify 4 categories of stakeholders. We have the data subject, which are individuals. We have the data holders, which are service providers that create accounts or identities and hold information for these users. We have the data intermediaries or brokers, which are entities that process the data on behalf of the data holders or aggregate them from multiple sources. And finally, we have data users, which are third parties that need access to personal data in order to offer their services. So CONSENTIS aims to utilize SSI and user-centric consent management in order to build security and trust and connect all these stakeholders. Now we can take a look at the use cases that we will use to validate our work to better understand how CONSENTIS will work in a real-life scenario. So the context here is that our user has 2 applications installed on their device. The first one is a symptom tracker app, which logs symptoms and measurements like blood pressure, etc., to a national healthcare registry. And also, the user has a wallet, an identity wallet installed in their device. So when the user starts to use the health app, CONSENTIS intercepts and builds a consent policy by informing the user about which data will be shared with which entity and for what purposes. Upon the user consent, a consent policy will be stored to the blockchain in the form of a smart contract. And also, an identifier associated with this consent policy will be registered in the user's identity wallet, and also to the CONSENTIS identity discovery mechanism, so that later this identity and the user can be identified in order to request consent for their data. The second use case is a secondary use case of use of data scenario. Here we have the same concept, but now the user wants to get a life insurance from an insurance company. For that purpose, the insurance company wants to validate some health data about the user, so it asks CONSENTIS about the location of this data. CONSENTIS discovery mechanism will identify the user and send them a notification asking them to give their consent about the location of their data. Upon receiving that consent, the insurance company will get the location, which is the National Healthcare Registry again, and request for the data. The Healthcare Registry then will check the consent policy of the user in the CONSENTIS blockchain. And since the user has not previously given their consent about sharing data with this insurance company, it will again notify the user and ask them to consent for sharing their data. Upon user's consent, the insurance company will get access to the data that they need. And finally, our third case is again a secondary use of data, but this time it is an exchange of big and aggregated data sets. So this time the insurance company wants to perform a case study, and for that it requests for a dataset from the National Healthcare Registry system, which will consist of users that fall under some specific criteria. The National Healthcare Registry will check about all these users that fall in this category, whether they have previously given consent about sharing their data for such purposes. For those who have already granted their consent, their data can be directly used in the dataset. For those who haven't, a notification will be sent to each one of them, asking them to allow the insurance company to access their data. For those who consent, again, their data will be used in the dataset. And for those who don't, we aim to use privacy-enhancing technologies to fully anonymize the data and include them. So in that way, we will make sure that we remain aligned with GDPR and similar regulation. So that was all regarding the CONSENTIS project. Thank you very much for your time.
Thank you so much, Kyriakos. And next, our speaker is Ignacio Lamillo and Laia Gota. The stage is yours.
Thanks. First of all, good morning, everybody, and thanks for having us. We will be presenting briefly our work in the DC4EU large-scale pilot, which, as you know, is one of the pilots funded by the European Commission through HADEA to test the capabilities of the European Digital Identity Wallet. And Laia will focus more on the part of the practical use cases that we are testing in the Spanish Medical Council for medical doctors. So let me check if I am able to move the slides. Okay, well, so first we will see a bit of the context we are working with, and then we will have a second part, which is the presentation of properly the DC4EU initiative, and then Laia will end by discussing the aspects of the Spanish Medical Council in the project. So as you may know, the context we are moving in is precisely the eIDAS-2 or EUDI regulation. This is a major advancement regarding the digital identity compared to the eIDAS-1 approved back in 2014. Some of the novelties include harmonized new electronic identification means, which is precisely the European Digital Identity Wallet, which will live alongside the other techniques we already have. Another novelty, perhaps the most interesting for us, is the introduction of a legal institution called electronic attestation of attributes, kind of electronic documents that we will be given the same legal effect of the paper documents they substitute. and therefore it is a new way to issue administrative information from the authentic sources. Another important contextual consideration is that this is not anymore just for public procedures, but it's also for the private sector as well, and it will cover legal persons as well. Now the Commission is working on the conceptualization of the business wallet, and which is something we didn't have before. And as it has already been said before by my colleagues, in this model, the user shall be in full control of the identities and data, and we are supposed to be in a system that does not collect too much information about the usage of these credentials. So from a legal perspective, here you have the legal effect of the new institution. As a lawyer, for me, this is very important because we plan to get rid of many cumbersome bureaucratic activities that prevent doing business properly, or even prevent medical doctors to work seamlessly in other countries. So for us, it is very important to have this cross-border recognition on the credentials we issue from this medical association. And it is also important to understand that we have two legal regimes. One regime is for authentic sources issuing directly, like the Spanish Medical Association, but we will be having a vibrant market of QTSPs having access to the authentic source to issue this information as well. So it is the first time we kind of compete between the authentic source and the market for certifying the same set of information, which is included in the authentic source for specific applications. Here you have a graphical depiction of this. This is very well known. It's published by the Commission in a particular website, so I will be skipping that. And to just highlight again that the most interesting concept for us in the regulation is not the wallet, of course, but the possibility of issue this kind of electronic attestation of attributes with full legal effect. So the idea is that just as today we are issuing some kind of documents in paper form that receive legal effect in our country, or for instance with the Hague Apostille in other countries, now we will be having electronic documents providing the same legal value. And of course, in this case, the authentic source is a new actor, which is very important because this is the place where we get the attributes. So somehow we complement what we already had in the eIDAS-1. The eIDAS-1 was limited only to a particular set of electronic identification means. Now we will be having the attestation of attributes as well. We have a prominent role for authentic sources, and now we can create a kind of data market on the hands of the users themselves, which is important to complement other initiatives we have in the European Union. So having said this, the idea is that we feel that the eIDAS-2 is not purely but SSI-alike approach, which is good, because if you look at the regulation, you see some properties of the system that evoke quickly what we've been working on, pure SSI approaches, like the ones anchored in blockchains. In this sense, the legal description of the system is okay in this sense, because we can read that data is under sole control of the user. We can read that there is a disclosure on data. We can read that we will be having full control of the use and of the data in the wallet. In this sense, it evokes, as I was saying, the desirable properties we've been working on in pure SSI approaches. And of course, it adopts the three-party model where we have issuers and verifiers exchanging data through holders without direct interaction, and therefore it provides us with new opportunities for exploring verifiable data registries, like we are doing in EPSI, for instance, in this case using a blockchain for implementing the solution while fulfilling the privacy and non-linkability and observability promises that are now written in the regulation. So again, for us, the key benefit of the eIDAS is for public sector bodies, and majorly. In this case, we have something that will allow the verification of the individual requesting an AAA using the PID. And with this, we will be able to issue any kind of data to the user, addressing thus the limitation of the data exchange protocols we have today. For instance, when we look at the interior market, we have the single digital gateway. We are using those mechanisms for exchanging data, but it is not possible to use them in all situations. Therefore, we will be relying on these new institutions for completing the system. And in this sense, from a pure legal perspective, this new EIDAS is kind of game changer because it provides an abstract approach to the reliability of any kind of attestation of attributes. So we have a trust infrastructure that will allow us to issue any kind of document, and anyone in the European Union will be able to accept the document, rely on the document content, and therefore transform the legal procedures where they need to consume these documents. But of course, this will force us to define the new types of documents and new type of processes. And this is what we are doing precisely by reusing some of the infrastructures we have. Let me check. Okay. And finally, in the context of the project, we started working with EPSI. So our approach was from the different techniques we could use. We decided to use the anchor-based solution of EPSI. Therefore, within this context, you can find the Digital Credential for Europe project. It is a project that it is finalizing next month. We've been working roughly 100 organizations from 22 countries during 2 years to test the wallet for being able to issue different kinds of credentials. In this case, the idea is that we are providing a kind of hybrid solution to be able to bridge the classical centralized and federated world with the distributed and decentralized world. This is why we decided to use EVSI as a trusted registry. And in fact, if you look at the project, the idea was to test interoperability and scalability, both in national domain and multiple cross-border contexts. I will let Laia to delve on that. The idea was also to show how a decentralized approach could become an actionable solution that would fit the EIDAS 2 requirements. Now we know that the EIDAS 2 is to be based on classical PKI, but still, for non-qualified attestations, we plan to complete and combine the model with a blockchain-based anchor trust service to inform about additional data for allowing relying parties to trust the content. And of course, we wanted to enhance the privacy of citizens by using this SSI alike. We have different packages of work. Working package 5 is oriented to educational credentials and professional qualifications. There we have different use cases. And we are complementing the work we did in the past around the academic diploma. And again, I will let Laia explain how is this being implemented by the Medical Association, which is a good example. But again, if you look at the three-party model, when implemented by DC4U in EPSI, you have everything in there. You have the verifiable registry based on blockchain. You have change of authorizations. You have verifiable attestations to define who can issue what. You have verifiable attestations for sharing data. You have verifiable presentations for getting access to data in a controlled way and validate everything. This is what we've demonstrated during the project. As I was saying, it is arriving to its end. We plan to provide additional feedback to the Commission around this hybrid trust model. And precisely this is why having real use cases was very important. And this is why I'm giving Laia the floor so she can present to you what we've been doing in the Medical Council of Spain. Thanks very much.
Well, good morning, everyone. So let's continue with this presentation.
Yes, Laia, you should have now the control. Yeah.
Yeah, great. Thank you. So basically to continue with this explanation that Nacho made us, we participated in this project because, as you can imagine, since the first years of education until you start working, there are a lot of exchange of credentials. So when you finish a degree, you get a credential saying that you have this degree. Once you want to start working, you need to present that degree. And while you are working, you get specific training. You can get other skills and knowledge that can be certified. So that's why we said that for doctors, it's very important to be there and to have these credentials to facilitate the mobility and the data sharing of doctors. So what we did in the Spanish Medical Council, we work in the C4U in two phases. The first one, which was mostly the first year of the project, we work on the definition of the use cases. So what are the credentials? What are the electronic attestations of attributes that we wanted to issue? What are the roles involved during the issuance of these credentials? Who does what? And then we also work on the definition of the business blueprint, which is basically a document explaining the as is and the to be. So what we have now, what we are doing now, and what we want to do in the future, and how we can do that. So it was most theoretical work, let's say. And in the second year of the project, which is phase 2, we've been working more in detail each type of credential that we wanted to issue. We worked on the typologies. We identified what vocabularies can be used to define these credentials. Of course, we wanted to reuse as maximum as possible. We used European semantic vocabularies, ontologies. And then for each type of credential, we worked on a document specifying the business rules of that credential. So how can that credential be used? And at the end, we wanted to start piloting, no? to issue to doctors these credentials. And now in last month, we are already finishing the pilot. So why we wanted to do that? Because Spanish Medical Council, we wanted to influence and to harmonize, standardize the credentials that are used in the medical profession. Of course, this work has been aligned with ADA2. The pilot was based on the trust model of EPSI, and we wanted to have an influence there, and so that these credentials can be used at European level. And these are the credentials that we worked. I will explain now in more detail each of them. But basically, we work on the identity of the physician. We work on the certificate of professional suitability. Then we work on the accreditation of the medical training, which is C4MIC in Spain. We also work on the certificate of the medical training. So once a doctor finishes a training, a specific training, so he obtains a certificate. And then within the project, there are other use cases related with health, which are the social security with a electronic health insurance card. So for the doctor ID, the doctor ID is used for a physician to access public and private sector applications, e-prescription services, for instance, or in the future can be also used for access the European health data spaces. Spanish Medical Council can issue these credentials because based on AIDAS or aligned with AIDAS, we are authentic sources, we are the secondary authentic source. We are the owners of the doctor's data, so we are recognized and authorized to issue this credential. Here in the right part of the screen, you can see the schema of the credential with a name, the surname. Medical board corresponds to the regional medical council of Spain. We also see the specialty, the medical specialty. So here we with all this data, we create the credential, and in the left side you can see how it looks like in the wallet. We already can pilot to have this credential in our wallet. First, we have to obtain the PID, our personal identification data, and once we have the PID, we can obtain the doctor ID. Then the second credential, and also very important, is a certificate of professional suitability. This credential allows physicians to, for example, carry out administrative procedures, and also if they want to volunteer, for instance, in other countries, this credential also allows that. Also allows to do so. This is interesting. In this credential, we have, for instance, an attribute which is legally entitled that once a doctor presents this credential and this attribute is true, it means that this physician is allowed to practice as a doctor. The accreditation of the medical training, well, this is based on continuous professional development and the continual medical education. This accreditation is also aligned with the European Medical Training Agency, which is WEMS. And here, I don't know if you will see it very well, but here we specify that the alignment of credits for Spanish training and for the European training. So there's this equivalence between the two frameworks. Let's say the Spanish framework for health credits and the European framework for health credits. And again, with that credential, then the doctor, this is quite, here. Then the doctor, once finalizes the training, can obtain the certificate accredited by the previous institution. And yeah, these are the use cases we've been working on. We continue piloting during the coming 2 weeks. So we will obtain all these credentials in our wallet, and well, we'll be able to share it and to use it through Spain institutions and also European ones. So thank you very much.
Thank you so much, Laia, Ignacio, Diana, and Kyriakoulis for sharing all the information of these great European projects with us today and sharing your time with us too. And now we get to the final part of our online webinar. Thank you for all the questions and all the participants who has been with us the whole morning today. And I give the stage to my colleague, Matthias Schuster, who is Trusted Coordinator and European Project Manager here at Gradiant. Matthias, your time.
Hi, Paula. Thanks. You hear me? You see me? Yes. All right. Thanks. Let me check if I can scroll. All right. Perfect. Thanks. Yes. So as introduced by Paula, I'm Matthias Schuster. I'm the project manager at Gradiant and actually part of the coordination team of Trusted. It's a pleasure to just share with you a final conclusion of this webinar. I have highlighted here some of the key points and key messages that have been shared during today's webinar. But if we have to summarize everything to provide a final conclusion and remark, is that at Trusted, we want to develop technologies that will enable data spaces. So as Jaime was mentioning at the beginning of the webinar, data spaces are of course no longer an idea, but these are already a reality. And in the complex regulation and in regards to data protection and data sharing, we want to implement self-sovereign identity and privacy-enhanced technologies to impulse these data spaces. It's not only, as we could see today, not only a matter of the Trusted project, but also the topics that we're financing this topic are going on that direction as well, as we saw from the sister projects of this topic. So this is a bit the main message. There are of course many challenges in regards to the implementation of this project, not only in terms of technological but also in terms of coordination. We are integrating complex technologies. We are talking about pets, of course, and self-sovereign, but we are talking also about data spaces, about federated learning, and other components that make this project complex. And for that, in order to be able to accomplish this, we need to have a lot of a good coordination system between the partners. We also encounter an added complexity, which is the ongoing regulation or ongoing legislation on data spaces. So as we were mentioning, this is a reality, but it's evolving quite fast. So it's difficult to develop a project at the same time as tracking everything related to data spaces. This adds complexity, but we think that it's challenges, of course, but it's part of also of the excellence of the trusted project. Before concluding, I would just like to briefly, very briefly, because we are running out of time, mention the next steps or what's next, not only in terms of during the project, we're still at month 9, but more on what's next once the project is finished. So we are already looking on that far. So we of course would look into future applications as the ones presented by Laia and by Nacho regarding the medical profession certificates and accreditations and medical training and so on. We will also look on other future applications because it has the potential to fulfill different sectors. We are, of course, as Gradiant, it's a technological center, we are really committed. It's in the Gradiant roots, the fact that we want to bridge the gap between research and the industry, and we think that this project does exactly this in terms of data spaces. And finally, we want to contribute to policy and standardization. So the idea is that the trusted project could serve as basis and as a contribution to evolve and to provide feedback on that regard. So with all of that, I would like to conclude this nice webinar. I would like to thank all the speakers and the presenters for the nice and insightful presentations. And I would also like to remind you that you can find all the information about the project in the website, in the trustedproject.eu, and there you have a contact link so that it directs to the coordination team, and you can of course ask any questions. You can also subscribe to the newsletter where you will receive all the information about the project. And we will, of course, have more webinars and more workshops so that you can also track the status of this project and also the nice topic that it introduces. So thanks a lot, and see you next time, and have a very nice day. Thank you.